Hey guys, this is Mr. Lauer here. This is some homework help for this worksheet assignment here, Systems of Linear Equations Practice. We have a couple methods of solving systems now. We can solve them by graphing, we can solve them with substitution, or we can solve them with elimination. Those are our three methods. This is going to focus on substitution and elimination, which are the two algebra methods. Okay, so we'll do a few from each section. We'll kind of practice those different techniques, different skills, and hopefully this will help you get going if you get stuck. All right, let's start here with number 4. Okay, when you look at a system of equations, one of the things that you want to look for is a variable that's all by itself, a variable that's already solved for. In this case, in number 4, you'll notice that y is all by itself, right, on its own side. This tells me that y is what I want to replace. Okay, so the word substitution here, another word for substitution or substitute is to replace, right? So I'm going to replace y with what it's equal to. I'm going to replace y with this. All right, so this will help you. This is a combination of notes and homework because we actually did a few of these in class today if you weren't here. So I did some of these problems, and so what we're going to do is we're going to make sure we take really good notes on this problem so that you can apply these ideas to the other ones. So use this kind of as your example problem. So what I'm going to do is I'm going to write over here next to the y, I'm going to write replace y. Okay, when the y is by itself, that means replace the y. Okay, and then I'm going to underline this, and I'm going to write with. Okay, replace y with this, and then we're going to write one more arrow to this other equation here, and we're going to put in. Okay, so replace y with this stuff in this equation. That's kind of what we're doing, right? And you can use that same model. So we'll kind of come here and do number 6 in just a second, but it's going to be the same thing. You're going to see 6, you're like, oh, x this time is by itself, so we're going to replace x. But the isolated variable tells you what you're doing, okay? So we're going to rewrite this top equation. We're going to rewrite equation 4. I'm going to write it right over here. But I'm going to replace y with this expression, right? So 3 and then negative 6x plus 12 equals 22. Okay, so let's compare here. 4x, 4x. 3y, 3y. Right, so I replaced y with this whole expression equals 22. Okay, so this equation is really just over here. It's just a little bit different. The thing is once you do the substitution, you have all x's now. Okay, so when you substitute, you're supposed to replace one of the variables so that you only have the other kind. So I'm going to make a little note to myself that says only x's, right? That's good. Now we can get x by itself. We just have to do a little bit of distribution and a little bit of solving. So let's start with the distribution, right? We're going to simplify this, so the 3 needs to get distributed, okay? I'm not going to touch the 4x for now, so I'm just going to bring the 4x down because that's not going to change. But over here, I got 3 times negative 6, which would be negative 18, and then 3 times 12, sorry, negative 18x, excuse me. 3 times negative 6x would be negative 18x. Then we got 3 times 12, and that'll be a plus 36 equals 22. Okay, so we just got a single equation. It's got one type of variable. We just now need to group that variable and get it by itself. Okay, so let's combine like terms here. Now these are on the same side of the equal sign, so we're going to combine the 4 and the negative 18. They're opposite signs, so they're going to work against each other. The difference between 4 and 18 is 14, but since the negative one's bigger, I know I'm going to end up with a negative number. Also, these are both x terms, right? So I'm going to have an x there. Okay, so these are the like terms. This doesn't have an x in it, so it's not a like term. Can't do anything with that just yet. So that's the step there. This is a combine like term step. Okay. From here, we just need to keep moving stuff away from the x's. So now that they're all together, I'm going to start moving stuff away. So I'm going to subtract 36 on both sides of the equal sign, right? Don't subtract 36 here because we want to subtract from both sides of the equal sign. So this is gone. All that's left with it on the left is this negative 14. So the negative 14 is going to come down, drop down. And then over here, when I combine 22 and negative 36, that's also going to be, that looks like a negative 14 as well. Okay. Okay, we're almost there. Now remember, this is a negative 14 times x, so we need to do the inverse of multiply by 14, which would be divide by 14. Okay, we're going to divide by 14 on both sides because we got to keep this equation even. So these cancel out, giving us an x or a 1x. We don't usually write the 1, so we're just going to write x. And over here we get negative 14 over negative 14, which is 1. All right, so we got one of our variables. Now when you get to this point, you usually feel pretty good about yourself that you did a bunch of algebra steps, and you kind of forget that we're actually not done yet. So this is half our solution, but we still need the y. Okay, so what we need to do is take this expression, take this value, and we need to plug in 1 for x in one of these two equations. It actually doesn't matter which one we use. They'll both give us the same y. So what we want to do is we want to pick the one that's going to be the easiest to work with. And in that case, this one is the easiest to work with because, again, y is by itself. And that's what we want. We want a y out of this. Okay? So the last step here is to go back and substitute again. So the first substitution gets rid of our y's. The second substitution tells us what y is. Right? So I'm going to rewrite the second equation now. Y equals negative 6x, but this time I'm going to put a 1 instead of x. Okay, and then we're just going to simplify, or evaluate, I guess is the right term here. So y equals negative 6 plus 12. Okay, well, negative 6 and 12, they're like terms. I just need to combine them. The one's positive, one's negative, and the difference is 6. But since the positive one's bigger, I know it's going to be a positive 6. Okay, so my solution here is 1 comma 6. So I'm going to put 1 comma 6. Right, that's my final answer here. Okay, I have nice organized work. Now it's okay that I kind of moved around a little bit. Sometimes you just don't have any space. But if that's the case, then probably what you want to do is maybe just draw some arrows to show which way you're going. Because now somebody could come behind me and follow this and be like, okay, these are your steps, step by step. People can see your thinking. They can see your first part of your solution, what you did with it, and how you got your final answer. Okay, and we'll go ahead and box our final answer. All right, so that's substitution. Now let's do another one really quick here. We'll take a look at number 6, and then we'll even go back and set up number 2. Okay. If you feel good about substitution, you might want to skip ahead to later parts in the video while we'll talk about elimination a little bit. And then at the very end of the video, towards the very end, I'll do some of these problems, the last 4, which are actually probably the hardest on here. So let's keep going with substitution for now, just in case you need some extra help. So look at number 6 for an example now. Okay, in number 6, x is by itself, okay, in one of the equations. So I'm going to circle this guy, and again, just for the sake of taking really good notes that we can use later, I'm going to say replace x. Well, what are we going to replace it with? What it's equal to. So replace x with this in this second equation. So I'm kind of running out of room here, but I know I'm going to replace the x in this equation. So find the variable by itself. I know I'm going to replace the x in this equation with this stuff. So let's rewrite equation 2. So negative 3x, okay, but now I replace the x. We're replacing all the x's with 1 minus 5y. Okay, but I keep going. Minus 15y equals negative 3. Okay, so again, let's compare what's happening here. So negative 3, negative 3. X, but instead of x, I wrote 1 minus 5y. Okay, then the minus 15y, and then the negative 3. So this is just equation 2, but I replaced x with 1 minus 5y. Okay, now again, notice when I do that, I only have y's now, and that's the goal. So I'm going to, again, put a little note to myself that this has only y's, which is great because now I can get the y's by itself. In the number 4, I replaced y with x's, and I had only x's. And this is the same kind of idea, I just did it with a different variable. Okay, so next we need to simplify this. Okay, I'm going to simplify what this says. We got to distribute the negative 3 and then we got to combine like terms, right? So we're just going to rewrite this equation. We're just simplifying it as we go. So negative 3 times 1 is negative 3. Negative 3 times negative 5y would be a positive 15y. Okay, we still have this minus 15y, and then we got a negative 3. Okay, we need to combine like terms. So these guys are the like terms, but 15 and negative 15, like they cancel each other out. We get a 0 there. So these go away since they're on the same side of the equation. We're going to cancel those out, and we're going to get negative 3 equals negative 3. Right? This guy equals this guy, which is an identity. Okay? So when you get an identity, you know that there is infinitely many solutions. Okay, now you don't always get an identity. Sometimes you'll get an actual solution, right? You'll get one solution. Sometimes you'll get infinite solutions, and sometimes you'll get no solutions. And we talked about that in class this week. So when you're solving a system, the three options are one solution, right? You could get, which is a point, a coordinate, like an x and a y. Or you could get no solution when you get like a contradiction. Contradiction looks something like 4 equals 3, right? An untrue statement. Or you can get infinite solutions, and that happens when you get an identity like the one we just got, negative 3 equals 3. Okay, so in number 4 we ended up with one solution, that's fine. In number 6 we got a identity statement, which means there's infinite solutions. Okay, so there's a couple of substitutions here. All right, now number 2, we're not going to do the whole thing, but I do want to kind of help you set it up. A lot of people find this like the most difficult to do. They're kind of confused on these, but this is actually the easiest kind of substitution. Okay, now notice y is solved for in both equations, so it actually doesn't matter which y you replace. Just pick one. Okay, so we're going to replace y with this stuff, but we have to replace it in the other equation. Okay, so we need to rewrite this equation, but we're going to replace y with this stuff. So y is the first thing we see. We replace that with negative 4x minus 9, and then we keep writing it. So really all that happens when you have both y equals is you just put these two things equal to each other. That's basically it. Okay. Now you can go from here, now that you have it kind of set up. You're going to have to get the x by itself, put all the x's together, solve for x, and then plug it back in and find out what y is. Okay, so just to kind of get you started on some of these. Okay, so that's substitution in a nutshell. Let's take a look at elimination. Okay. With elimination, we are trying to get rid of a variable as well. We just do it in a different way. But most of the time when you do elimination, you're going to see your equations in standard form. Okay, so notice that your x's are like stacked on top of each other, and your y's are stacked on top of each other, and then your numbers are stacked up on each other. Both of these equations are in standard form. So elimination is going to be a really good method here. So all we're going to do is we're going to draw a line under this guy, and we're going to add the equations together. We're going to combine the x's down this column, we're going to combine the y's, we're going to combine the numbers. Okay. Now sometimes there's an extra step right here, which we will talk about on the next problem, but this one's actually pretty easy because when you combine the x's here, they go away, which is kind of what we want. So if I combine the x's, they actually kind of eliminate here, right? Negative 3 and 3 cancel each other out. Same thing with y and negative y, those cancel each other out. Okay, I still have an equal sign, equals, and then when I combine these two, I get a negative 8. Okay, now if everything cancels on the left-hand side, we need some way to indicate that we canceled everything out. We can't just like lose a side. So if everything gets crossed out here, what we need to do is we need to put a 0 there. Okay, so 0 on the left, negative 8 on the right, and what we get here, this is a contradiction like we just talked about a minute ago. And whenever we get a contradiction, we know that there's not a solution. So the answer isn't contradiction. Contradiction is just a label. It's a type of equation, right? It's an untrue equation, basically, or an untrue statement. So this thing I just labeled as a contradiction just so you can see that that's what we got. But when you get a contradiction, your answer will be no solution here. Okay? Now 7 is actually really, really similar, but it works out slightly differently. So let's take a look at that here. Okay? Again, I'm just going to combine the two equations, add the x's together, add the y's together, add the numbers. When I do that, only the x's eliminate. And that's typically what we want. So the x's go away, we got no x's there. The y's don't go away though. When we combine here, we get a 5y, and then the 0 and 15 gives me a 15. So this actually, it didn't give me a contradiction. This isn't actually working, but this is the key. We want something to eliminate. We want one of the variables to go away, and in this case, we got rid of the x's. We got to keep solving this guy, so we're going to solve both, or excuse me, divide both sides by 5, and we get y equals 3. Okay, pretty good. Now we're almost done. We just need to find out what the x is. So we got to take this guy and plug it back into one of the equations for y so that we can solve for x. It doesn't really matter which one that we do. They're both going to give us the same x. So I usually pick the one that looks the easiest to use. And a lot of times that means, for me, the one that doesn't have negatives in it. So I'm going to use the second one here. So I'm going to rewrite the second equation. But wherever I see that y, I'm going to replace it with 3. All right, so 3x plus, this is going to give me 18 equals 15. Okay, so 3x equals negative 3. If I subtract 18 from both sides, I should probably write that in. I'm going to get 3x equals negative 3. Okay, I'm going to come up here and keep going. Now I'm going to divide both sides by 3, and I'll get x equals negative 1. Right, so my final solution, x was negative 1, y was 3. Remember, your solution to a system is an ordered pair, which is like a coordinate, an xy pair. Okay, so both of these use elimination. The key is that, you got to get one of the variables to cancel. Okay, in this case, they both cancel, which kind of gave us something funky. This is a more normal version of this kind of problem. But let's kind of, see what happens as we keep going. All right, so let's do a couple of these. Let's just take a look at number 10, okay? Now let's say we did exactly what we did before. Let's say we just add down the x's, add the y's, add the numbers without doing anything, okay? 7x and 14x is going to give me 21x. Negative 2y and negative 10y is negative 12y, and then 20 plus 16 is 36. Okay? Now this is a true statement, but notice that I haven't really made any progress here because I haven't eliminated a variable. I'm not getting any farther. I still have an x and a y, and that doesn't really help me out. So the goal here is to get something to go away. We want something to what we call eliminate. Okay, that's kind of the idea. So we need what we call additive inverses. You don't have to memorize that phrase, but what I mean by that is we need something like this. Negative 14x and 14x, right? That would work. Those would cancel out, right? Or we could do like negative 2y and positive 2y. Those would cancel out. Or, 15x and negative 15x. We need the same number, but one positive and one negative so that we can actually cancel it. So when you look at these equations up here, and you're kind of wondering, what to do, we basically need to multiply one of these equations by some number so that we can get the elimination happening. All right. Now I'm noticing that this here is a 14, and this right here is a 7, and I know that 7 goes into 14. So all I need to do is multiply this top equation by negative 2, and this all of a sudden will be a negative 14, which will cancel out with this 14. So I'm going to multiply the top equation by negative 2. I have to do that on both sides, otherwise the equation is not going to be true anymore. So I got to keep it balanced. And when I distribute, I'm going to write my new equation down here. So negative 2 times 7x is negative 14x, and that's exactly what I wanted to have happen. Okay, negative 2 times negative 2 is positive 4y, and then negative 2 times 20 is negative 40. Okay, so equation 1 is now right here. I just rewrote it. I multiply both sides by negative 2. This is still equation 1, it's just a different version of it. Okay. I don't really need this anymore. I got it right here. Okay, I might use it later at the very end of the problem, but for right now I don't need it. Now we do the elimination. Okay, notice it didn't work before. Sometimes we have to do some work to get it there. But now I have a 14 and a negative 14, and that's going to cancel. Okay, the negative 10y and the 4y are going to give you negative 6y, and then the 16 and the negative 40 are going to give you negative 24. Okay, so now we're getting somewhere. Okay, we got to get y by itself, so divide both sides by negative 6. Y equals 4. Okay, we're not done yet. We got half of our solution. We just now need the other half. Okay, so we got to plug this y equals negative 4. We got to plug negative 4, or sorry, y equals positive 4. We got to plug 4 back into one of these equations. Okay, we have the original 7x minus 2y equals 20. We have this guy, 14x minus 10y equals 16. We have this guy, negative 14x plus 4y equals negative 40. It doesn't matter which one you use. You can choose any of those. So I usually choose the one that has the smallest numbers, that looks like the easiest to work with. Okay, so in this case, I might go back and say, you know what? Actually, the original equation has the smallest numbers. Maybe that's the one I want to use. So I'm going to use that original first equation. So 7x minus 2y, so 2 times 4, equals 20, right? Replaced y with 4. So 7x minus 8 equals 20, okay? I'm going to come up here, so I'll draw an arrow to indicate my workflow. Okay, I'm trying to get x by itself, so add 8 on both sides. Okay, 7x equals 28, sorry about that. And then divide both sides by 7. So x equals 4. So the x is 4 and the y is 4. That's okay. My solution then would be the ordered pair 4, 4. Okay, so that's an elimination. Now keep in mind, some of these are going to have no solution, and some of these are going to have infinitely many solutions. It just depends on what you get. In this case, I got a value for y and a value for x. But sometimes you'll get a contradiction, right? Or you'll get a identity. Sorry, I was spaced out on the other word. And if that's the case, then you need to put no solution, or you need to put infinitely many solutions. But we've already kind of talked about what a contradiction looks like. Right? Contradiction looks like an untrue statement with just numbers, no variables. An identity statement looks like a true statement with just numbers and no variables. So you kind of know what to look for there. All right, let's look at some of the other problems. Now 13, 14, 15, and 16 are the hardest, and the reason why is because you actually have to multiply both equations. Okay? In this one, it was pretty easy to get the elimination happening, right? I was like, oh cool, I can turn that into a negative 14. Perfect. Okay? But if you look at, like, let's say 14, for example, I can't get that to be a 5 by multiplying by a whole number. Like, I can't multiply something by 3 to get it to be 5. That's not going to work. And I can't multiply something by 6 to get it to be 8. It doesn't work. So I don't have like an easy multiplication. In this case, and actually in all 4 of these, you're going to have to multiply both equations. And if you want to make yourself a little note, you can do that. So these last 4, I believe, you're going to have to multiply both equations. Okay, so you can pick, it doesn't matter if you do x's or y's, you just need to figure out something that both of the numbers go into. So for example, 3 and 5 both go into 15. Okay, so I can get this to be 15 and this to be negative 15. All I have to do is multiply the top one by 5, because 3 times 5 is 15, and multiply the bottom by 3, because 3 times negative 5 is negative 15. Okay, so let's do that. We're going to multiply the top one by 5. On both sides. Okay, when we do that, don't forget to distribute, so the 5 has to multiply both pieces, and it has to multiply this guy over here. So all together, when we do that, that's going to give us a 15x minus a 40y equals negative 40. Okay, the bottom one we need to multiply by 3, and that's going to give us negative 15x, which is exactly what we wanted, right? This is going to work out really nice for us. Okay, 3 times 6 is 18, so 18y here. And then we don't forget to multiply by the 3 on the right, and that's going to give me negative 48. Okay, so now it will eliminate. Now we can set this up. And we didn't have to eliminate the y's, or the x's, excuse me. We could have eliminated the y's. If you think about what 6 and 8 both go into, they both go into 24. So you could like multiply this one by 4 and this one by 3, and you'll get a negative 24 and a positive 24. That would work. They also both go into 48, so you could like multiply this whole equation by 8 and this whole equation by 6, and you would get those eliminating. So you have some choices here. I just thought the x's looked easier because they were smaller numbers to begin with. So these are going to go away. That's the elimination part, right? And then we're going to get a negative 32 right here equals negative, and if we did this right, this should be, oh, sorry. That's not negative 32. That's going to be negative 22, excuse me. Negative 22 equals negative 22y. Sorry, geez. Okay. Negative 22y equals negative 88. Okay. Still trying to get y by itself, so divide both sides by negative 22, and we get y is equal to, that's going to be a positive 4. Okay. Negative over negative is going to cancel. The negative's going to cancel. Okay. All right, so now I have my y. I'm halfway done. Okay. I need to plug it back in and then find out what x is. Okay. Now I have some options. I actually have 4 equations now because I have the original one, original equation 1, original equation 2, and then I have like the new equation 1 and the new equation 2, and I could plug this y into any of those 4 equations and it would give me the exact same x. But I like to pick the one that's going to make my life the easiest. And I like that equation 1. The original equation 1 looks really nice to me. So I'm just going to use the original equation without the 5's. Like this was, you know, before we multiplied it by 5, before we changed it, right? This is what it looked like. Sorry. So 3x minus 8 times 4 equals negative 8, right? Because y now we know. So 3x minus 32 equals negative 8. Okay, we got to add 32 to both sides. That will get rid of that guy. And now I have a 3x equals 24. Okay, divide both sides by 3, and x is equal to 8. Oops. All right, so we got our x, we got our y, we got ourselves an ordered pair. There is our solution. Okay, so you're going to have to, these last 4, you're going to have to multiply both equations. Okay, let's just take a look and see like what we might be able to do, right? Okay, 3 and 4 both go into 12. So I could get this to be positive 12 and this to be negative 12. All I would have to do is multiply the top by 4 and the bottom by 3. So that would work. I don't have to do both, but I could also do the x's instead if I wanted to. So 7 and 10 both go into 70. So I could multiply the top by 7 and the bottom by 10, and I get a 70 and a negative 70, and that would work. Let's look at 15 really quick. Okay, 4 and 3 again both go into 12, so I could get a 12 and a negative 12. If I multiplied the top by 3 and the bottom by 4, I would get a 12 and a negative 12. Okay. In this case right here, both of these go into 14. So if I wanted to, I could multiply the top equation by 7 and the bottom equation by 2, and I would get a 14y and a negative 14y. Okay, now of course the other numbers aren't going to match up, but that's okay. I only need either the y's or the x's to match up and eliminate. I don't need both. If it happens that they both eliminate, that can happen. You know, that might be the case, but you only need one. Okay, over here, 6 and 10, what do they both go into? Well, they both go into 30. So if you multiply the top by 5, everything across the top, you'll get a 30x up there. Okay, now we want to multiply the bottom by a negative 3. We want a negative number there. So if I multiply the bottom by negative 3, I'd get a negative 30x. So 5 on the top, negative 3 on the bottom would work. The y's look pretty big, so I don't think I would want to mess with those. But that should help you get started. That's several problems from both sections. Lots of extra examples for you. Okay, really good practice for your algebra skills. There's all kinds of important algebra skills happening in here that are going to really help you out in the future, in your future math classes. So some of these are multiple steps and they're maybe a little bit complex, but if you can handle these and grasp these, then your algebra skills are getting pretty sharp. So thanks for watching, and hope to see you in class pretty soon.